Okay, it's noontime. We'll get started, okay? First, I'm going to answer questions. So, because this Monday, we are supposed to solve the problem for you, okay? To help you to get things, solve your problem and answer your questions. So first one, I'll actually answer Joseph your question. Actually, I see you keep sending email, but it's very hard to track your email content to see what's wrong. Okay, so what I would do is like using this Zoom session to answer your question. That would be better. If you need a quicker response, I'll suggest you to become a friend in my website. Right here is a Facebook/Dr. Dr. Eric Chow. Okay, so that's you come here and you request for friend. And I'll add you in. I have tons of friends, more than 300 friends. Most of them are parents or kids. I do teach some high school students, so they are parents as well. But if you sign up this, you contact me. I may Zoom you if necessary, okay? Is that okay?
Yep, for sure.
Because email, it's actually really hard to communicate. I mean, just look at whatever you have. It's really hard to give you some advice or change your design. So I suggest you either come to this session here or you actually become a friend. And I usually every year there are probably a couple of students will sign up here, okay? And I will answer question. Some of them no questions, so up to you. Okay, anyway, go back to your question. You have a question regarding the program assignment 3. So program assignment 3, let's look at the problem one more time. And then actually last week I already answered the question for this one. I don't know whether you missed the class or did not watch the recorded video. We do answer the question. And then your question actually is whether there's a joint 3 should be rotational or a fixed. My answer is that either way, I will accept it because last time I already said it, but let me make it clear one more time. So this is a programming assignment 3. We actually discussed it last time, and what I say is, okay, you need to watch this video, okay? The video. These actually will help you to solve the problem. Teach you how to solve the problem actually.
Yep, I've definitely had those on repeat all
Yes,
weekend.
no
So
problem. Okay, let's look at one more time the project. Okay, in the project actually right here, this one is smaller, so we consider it just a holder. It's not a rotational joint. So what you need to do is that you have the friend 0 right here, friend 1 right here, whatever orientation you need to set up. Friend 2 right here, and your 0, 1, 2, 3. So you totally 4 friends, 3 join. So this one you consider to be an extendable prismatic joint right here. So between 2 and 3, you will need to factor in these and these. But this is fixed number. These are not extending or rotation. There's no rotation right here. If you model this one as a rotational metric, that's fine. And then you will end up with 5 frame, 4 join, 5 frame. But that's not necessary. That's actually optional. So last week I already tell every student this one is optional. So when you vector in here, let's assume that here you do have a XYZ. You just think that is a head. With respect to this XYZ, you should have an arm like this. You should have a displacement in this direction. So you need to set up your displacement of the X, Y, Z appropriately. And your matrix should have 4D because you have the X, Y, Z, and W. W is 1.
ನಾಳೆ important on ಮಧ್ಯಾಹ್ನ ಹೇಳ್ಬೇಕು
Can
ಕೇಳ್ತಾನೆ.
someone mute your if I'm talking? Is that okay? Sorry.
ಹ್ಮ್.
And then this rotation of 3 by 3 over here. So you need to set up the displacement right here. That's the only thing you need to do for the matrix between friend 3 and friend 2. Is that okay?
Yeah, no, I absolutely understand that. Yeah,
Okay,
I,
so that's what I can tell you so far with the chart. Now it's your turn. You show whatever you have that you believe that you still have question on.
yeah. So for me, what I'm actually having problems with now is the code when you're applying the coordinates to the HTM because when
Yeah, show me. Show
yeah,
me your
yep,
show me your code.
pulling it up one moment. Two.
Basically, it's a friend to friend. You need to consider the displacement. You need to consider the orientation. You also need to consider the rotation.
Yep. Yeah, can
So,
you
so you need to set the rotation and the orientation metric as two separate metric. But the displacement need to mix with the rotational metric to make it a HTM, the homogeneous transform metric.
yep.
Okay.
But can you add permission to let me share?
Permission. Let me see. Okay. Let me see. Okay. You cannot share at this moment. Okay. I make you a co-host, so you actually should be able to host.
Okay.
Check if you can.
Yep,
Okay.
there we go. Yep. All right. Yep, can you see my screen?
Yeah.
Okay. Yep.
So
So
you show. I didn't see your share part. Let me check. Okay. Let me see.
yep.
Let's see. I still haven't seen your sharing part.
I'm sorry, are you referring to the output or are you referring to like it's not showing on the screen?
I did not see your screen. You are showing of your chart,
Oh,
whatever.
there we go. Sorry about that.
Yeah.
Okay.
So what is your question right now?
Okay. So basically, I go through and do all this, rotation matrices are orientation times the
Mm,
rotation.
mm.
The displacements are set. Um, the thing I'm having problems with is like between here and
Your displacement need to merge with the rotational metric.
correct. Yep, yep. And I do that here
Yeah.
in the HTM matrix. However, when I apply my final, HTM, that's the dot of, H01 through H04, um,
Yeah.
I don't get a point that makes much sense to, the degree of angle. So
That
like,
means you have numerical problem. You calculate, but it doesn't get the number you expect.
yep. So like for instance,
Then you have to debug your metric. That's what I can say.
I'm sorry, say that again.
You have to debug your metric step by step.
Yes, and I've done
So
I've
what you should
done
do
that.
is that you actually do the friend 1 to friend 0 and then make sure it actually is okay before you merge every metric together.
Yep, and I verified each rotation matrix. I
Yes.
verified
And then
each
what happened?
displacement, and so the thing is whatchamacallit, I don't have a problem all the way up until when I actually do the starting point. Like the HTM generally makes sense for where it needs to be, but when I put an application with the coordinate point, it doesn't make sense.
It doesn't make sense because do you really make the metric correctly or no?
Well,
So your
I think I
starting
did.
point is your starting point. Let's see. You put your starting point. Let's assume that you are actually as friend 3, you have a starting point. This starting point is with respect to friend 3. So this one you need to convert with respect to friend 2 and then friend 1 and then go to friend 0. Then you actually there's a certain point that coordinate is actually with respect to friend 3. You actually convert it correctly to friend 2, then friend 1, and then friend 0. From friend 0, then it's actually the right coordinate based on this structure to see this point. You need to backward check it, not a frontward check it. You're not from friend 0 to friend 1 to friend 2 to friend 3. You actually need to backward check in when you apply the address. That's what's commonly seen problem when some student mess up.
Okay, so then whatchamacallit? So I do have, the HTM
You need
matrices.
to see if the number you say is actually with respect to friend 3, you need to convert it to friend 2 first.
Yep, and I do this with my reverse HTM
You need
here
to make
from
sure the data is correct.
Yep, and I
Yeah.
I've went through and verified this a lot, and that's kind of where I'm at a loss of words as to
Yeah,
what
but if
the
it still
problem
doesn't
is.
make sense, that some of your metric is wrong. That all I can say. How otherwise how can we do? We have to verify it step by step. You know what I'm saying?
Yeah, no, I absolutely understand. Yep.
Otherwise, if your metric is correct, it should give you the right or expected answer that you can look at. But usually the problem is you need to know that you are reverse checking the address. You have to know that you are based on X3, Y3, Z3. You need to backward calculate X2, Y2, and Z2. The metric need to be in the reverse way, not the forward way. You know what I'm saying?
Yep, no, I absolutely, and I've kind of gone back and forth with doing that too, and that I guess
Yeah.
that's kind of adding to confusion.
So if you do reverse some of the metric originally let's talk about it. Your rotation is doing the theta, right? If your object rotate in this way, but if your coordinate rotate, say let's assume that you rotate this way with a phi. I'm sorry, with a phi. Then effectively if this point not changing, your frame actually is rotate backward minus phi. Usually that's the problem that some students mess up. So you need to be careful when you really apply the theta or phi. Must be in the right direction. Coordinate change is the opposite operation of the object movement. And in this way, usually your friend 2 to friend 3, you have rotation and your coordinate actually change because of the rotation. So your object, if no movement, it actually is actually primarily changing according to the framework. So accordingly, to what you say, you already set up every rotational metric correctly, and you check every step. Then, if there's no numerical error, you should get the right or expected result. You know what I'm saying? Other than that, how can we help you here? You theoretically, you know what you are doing, right?
Yeah, and I think that's kind of what it
Then
is. Yeah.
then you have to debug. You have to debug. There's no other way to do. You know what I'm saying?
Yep, and yeah, and I've rewrote this code about 3 times. So yeah,
I
I'm
know,
I'm just
but
trying to understand what the
yeah,
problem is.
you still need to check. I mean, if you still haven't solved it, you still need to check. And what else can I do? I need to run your program and see where it went wrong, right? That's the only thing we can do right now.
Right.
Okay. Any other question?
Yep, that's all I got for you.
Yeah, you have to run it one more time. And I would check your program when I run it, okay? Okay, any other question, other student? By the way, some student claim that he submitted kinematic diagram, but in fact he didn't. He just give me a output diagram. That's not kinematic diagram, okay? He's completely not looking at my video. So I don't know. Some students just want to do that. And some students never check the video, especially the left parts, and then complain that they don't know what to do, okay? That's also wrong. Usually, if you make every metric in the right way, but you didn't get the vector like what Joseph just described, usually I don't deduct too much point for you. Okay, so don't worry. I look at whether you get the right mathematical modeling process or not more. But I'll try my best to debug if you do make a mistake. You know, any of the cosine theta or sine theta, you put the wrong number, you end up with wrong result. So it's a very tedious debugging process, I should say. You screw up any of the cosine or sine, minus sign or plus sign, you actually will screw up. So that is a long debugging process, okay? If you really put everything correctly, you still may get wrong answer because just some typo or some minus sign you didn't put there.
Yep. And Professor, real quick, I just want to do a sanity check with you. So if we have a starting point at 100, if we had a 0 degree of rotation, we should theoretically be at 200, correct? Not a displacement of 1 plus the displacement of 2. So it should not be 3. It should be 200 start.
Let's assume that you do not rotate, right? Let's assume that you do not rotate. And you are here, your frame 0 is right here. And your frame 1 actually is up here. You do rotation on frame 1 here. You do have a frame 1 here. You do rotation, but you didn't rotate. So let's assume your XYZ is still here. And this point right here, let's assume it's 0, 0. I'm sorry, let's assume it's actually 1, 1, 1. So let's assume this part from the frame 0 to frame 1, your G increased by 1. So theoretically, if you don't rotate, this point with respect to 0, frame 0, it should be 1, 1, 2, right? It's actually no brainer. You just add some G over there, right? So this can be expected in this way. But you do have the orientation, so you have to consider the orientation into there to see what is the number makes sense or not. But usually if your friend just move up by 1 distance over here, and you are respected to the frame 1 as 1, 1, 1, then it respect to 0, it should be, frame 0, it should be 1, 1, 2, because there's only one difference between frame 0 and frame 1 in G direction. So that's something you can check if actually is right. You just make no rotation on anything. You make no rotation on anything, what you should see is that after metric calculation, it's just everything just the displacement. Is that okay?
But the displacement added to the original
Added to
starting
the
point.
original starting point, yes.
Okay. Thank you.
If no rotation at anywhere, no extension anywhere, right? And the last one, you have the extension, so you can calculate, it just change on the Z direction. So you can do that kind of a check as well. Does that make sense?
Yep, thank you.
A student asked that how is that possible that you don't rotate? No, we just want to check the baseline expectation, okay? We later need to add a rotation. We here just saying that for you to check your displacement part. You keep everything no rotate. Theta always 0. Then you can see that no rotation where your coordinate should be. Is that correct or not? Okay. And you need to take your orientation into consideration. So when you take the orientation into consideration, you have to go through the lab that we have. What we have the so-called the dual, the so-called right-hand dual, those kind of dual. When you apply different metric on it, there's a so-called right-hand duals, and there are 3-4 rules that you need to follow before you go set up your metric. Okay, those we don't have time to go over because only explaining those rules take a long time. But right here, I will show you the dual one more time. It is in the lab. You have to watch the video, and it is included. Okay, but if you don't look at it, you cannot solve the problem. So here, let's see. I'm unreached. Let me check. Okay, it's one of the video we have. This one. I'm sorry, not this one. So this is set of the video in the lab. I call it the undergraduate part. So it's not a lot of math. It just teach you how to operate the metric, how to operate everything. So actually, it give you a better sense of what it should be. There's a rotational metric. So here, this one teach you how the rotational metric being done, and then orientation metric as well. Okay, now this one, we still have the one that set up the so-called XYZ direction. Let's see, displacement vector. This one, you include a displacement vector in there, and then we explain what is displacement vector and the combination of that. Actually, we explain it in detail. And we also look at the kinematic diagram, what it should be, okay, and how to model it. And then when you model the SYD, we do have a rule of three rule to apply which one should be X, which one should be Y, okay? We explain in detail of different situations. So we go through every single type of the metric. You have to watch this, okay? If you don't watch this, actually, you may miss. We do go over different type of robot. And then it's a homogeneous transformation. This one teach you how to combine the displacement and rotation together.
I'm in class.
I don't
I'll talk to you in a little bit, Greg. Good to see you.
Yeah. Any question? I actually still don't find the one that we talk about right-hand rule. There's a one that talk about right-hand rule. Not this one. This one is the homework one. Okay, if you read somewhere in there, I don't think it's in the inverse metric. No, it's not. It's actually passed it already. There's one on right-hand rule. I cannot find it right now. Sorry. Maybe in the kinematic. Let me see. Right here. This has the right hand rule. Talking about the right hand rule and then how to assign the XYZ. So you have to assign your XYZ according to this one. This one actually on a kinematic diagram, they tell you usually which Z you should define. Okay, your Z should define. There are several rules that we prefer. So you have to follow it. Number one, there's a XYZ need to follow the so-called right-hand rule. Okay, that's the right-hand rule. Actually, let me show you. We use the right-hand rule because you need to follow the cross product. Okay, let me make my window bigger. Okay, so my hand, okay, my hand right here. So this is my right hand, right? My right hand. So basically you have three direction, X, Y. Okay, I'm sorry, let me move back. Okay, this is my right hand. I don't see where this one is right hand, okay? So use your right hand. I'm actually opposite side. So your X direction is where your finger pointing to. This is your X direction. Your Y direction is where your palm facing on your right hand, your palm. So you have X in this direction moving forward, Y this direction. So your Z should be in this direction. This is called right hand rule. You actually cross and sum up, cross and sum up. Okay, it tell you the X direction, Y direction, and Z direction. Why we do this? Because the cross product, when we do math and we have a cross product, when we have the vector, we had two vector. Let's assume we have two vector, X vector and Y vector. Cross product, you say X dot Y, you have a cross product is equal to X length times Y length times cosine theta. Is a theta right here. It actually is the projection of X to Y or Y to X, but multiplied by the length. Okay, that's called cross product. And I'm sorry, this is called inner product. This is called inner product. And cross product is different. Cross product is also a mathematical definition. You do have X and you have Y. Okay, so your palm is right here, right hand palm. Finger pointing to this direction, palm pointing to this direction. So you cross your palm over here, your thumb will be in this direction. So this is your Z. That's how you define your Z direction. Okay. So before you actually just fix your frame, you have to determine the right XYZ direction. It's not always the same. Usually your rotation is on Z here. You will have your rotation either this direction or this direction, because right here you are rotating along this axis. But this one or this one, you have to determine by your XY and your right hand rule. Okay, that's the fundamental idea. So these four rules just help you to set up the right way to determine your XYZ direction. And usually from mathematics, this is one way you do right hand rule, but you can also use the way that I do, usually that I do is that your finger per direction is A direction. Your palm is facing this way. So you do not need to have a separate finger. You actually use your palm and you cross over, your thumb direction is up here. That's your A cross product B's direction. Okay. And what is the cross product? Later, you will figure out what we need for cross product. But cross product is a very commonly use the mass. Okay, when you use what? Use the leverage in physics. Okay, use rotation. A lot of things actually related to this right-hand rule. In actually also the electrical field also need this right-hand rule. Anyway, these are what 4 rules you need to follow before you draw correct kinematic diagram, and then you model your mass based on kinematic. So this video, I would say, very important before you apply any technique or metric to it. You have to figure out whether your KD is designed the right way or not. Okay, if not, then you end up with wrong answer as well. Is that okay so far on this KD part? That's why every time we need you to include your KD. Because from there, I will know that how much you really know it. So some of you don't include your KD, then I'll deduct 10 points every time, okay, if you miss the KD part. Any questions so far? Any questions so far? So kinematic diagram in a way showing you how your metric move, according to which axis, where you do transformation, okay? So the purpose of KD is to model the different joint, and then Denavit-Hartenberg parameter is a systematic way to build up your homogeneous transformation metric. It is systematic way. So it kind of, you have 4 joints, you need to have 5 frame. And this 5 frame, you do have different theta, alpha, A, D, the different parameter. And these parameters invented by Denavit and Hartenberg is used to systematically set up your metric. So that's the purpose of this Denavit-Hartenberg frames. So first, you need to know about KD. Second, you need to know about homogeneous transform metric. And then eventually, you need to apply this Denavit-Hartenberg metric to model your transitions. Okay, that's the whole process. So first homework, we only working on rotation, but no displacement. Second one, we work on, I'm sorry, that's a program assignment 2. Program assignment 3, we work on what? Work on the so-called rotation metric already. So you need to apply homogeneous transform metric at least. Homework number 4, we work on workspace. And that's another issue you need to know. Right here, I'm going to talk about homework number 4. Let me show you the slides first. I'm sorry. Let me show you the slides first before we go for the discussion. So homework number 4, let me check. Let me check. I'm sorry. Let me look at the course share. Okay, I'm sorry. We should go from course share to get it. That would be easier. So let's go to week 4. Because our code share, we use it for many, many times. So I would say all of the things that you need will either be in the video or in the lab. You will have it, okay? If you don't know how to do it, usually it's you miss it or you did not watch it. Okay. Okay, right here we do have this different thing. Okay, this program assignment number 4. So here you need to submit your description for workspace. Okay. So number 1, you need to know what is workspace. Let's assume that you are a baseball player, okay? Okay, whatever stand you have. You have a bat. Okay. Your hand may go up and down, so your hand may go up and down like this. Your bat may go lower. So the so-called workspace is that if you can hit the ball maybe here, maybe here, maybe here, okay? Different part of your bat. So all of the spaces that you can hit, whenever you swipe, you actually swing your bat, and let's assume that let me get the pen. Okay, so I have my hand and I have a pen. Okay, I'm sorry, the pen doesn't show. So this is wherever that I can hit using this bat, using this pen, wherever I can reach using this pen in the space, it's my workspace. Okay, wherever I can hit with the bat in my workspace. So in the baseball situation, let's assume your hand is right here, and you have your upper arm, and then you have a bat. Okay. So if you make it straight, it's like only one bat. Okay, not two joint actually, and everything you can swipe is right here. That's your workspace. It's actually a circle, or even maybe it's a donut shape stop. Does that make sense? Donut shape because your bat may go this way like this, according to the circle of your joint on your arm. But robot do not have the problem of backward rotation, right? So robot can go as much. So that's when you consider your workspace, you have to think about it in that way. So workspace is where your bat can go. Does that make sense? Where your robot arm can go, can reach, is your workspace. So here, it's not kinematic diagram only. You need to show me the so-called workspace. Submit the mathematical design. So what is your workspace model based on wherever you can reach by your robot arm? Is that okay? So if I only have a rotational joint and only one pen, so when it rotate, it will actually be 360 degrees. It will be a circle. But if you have two joints, where can I reach? That's the question. You have to answer that question. Okay? Any question? So you need to build up a mathematical model and also show me how it works and what is the workspace. So this one we are discussing workspace, not discussing KD all alone. Okay. And that's different modeling your workspace. And later we need to understand workspace in order to know about the inverse kinematic diagram, inverse kinematic operations. And then we need to trace back to find out the path of a robot, how you manage your robot to reach the workspace. Any questions so far? Hello, any questions so far? No question?
From me.
Okay, one more thing I would like to say is that if you really have some problem, you want to reach me, it's better that you just actually just send me a friend request to my website. Okay, my website is my Facebook page. It's very simple. It's just facebook.com/Dr. Eric Chow, right? That's actually very easy. I
I
set
don't
up.
have Facebook, which is why I've been emailing you, and I appreciate the responses on there.
Yeah, but Facebook you can just join. That's not a problem, unless that you don't like it.
Yeah, I don't have an account, so
Yeah, you can
I'll
hit you up
just
on email. You just set up a account. Well, if you send me email, I cannot do Zoom session with you. So if you do Facebook, usually I send out the Zoom link through Facebook real time, so I can reach you and I can answer your question faster. That's what I want to say.
Professor, actually, it is not allowing me to send a friend request to you. When I try to send a friend request,
You do it now. I'm going to add you as a friend right now.
no. When I send a request, it is showing me that you cannot send a friend
Yeah, you
request.
do it right now.
Yeah, sure.
One more time.
Yeah.
We solve the problem right away. Okay? No matter what happened, I don't know. Unless you block some friend or something, you have US security set up. Usually it doesn't happen that way, okay? What I see is that there's no one sent me the request so far, so I don't know what happened.
Actually, it is showing me that can't send request, Professor. The message it says that
You share by room right now. Let me see what happened. If Facebook block you, then I cannot help you, right? So that's too bad. So you share your screen right now, how you add it as a friend. Or if you have question, you can post your question. Because right now it's a room session, I can help you to solve the problem if you have.
okay, Professor, give me a moment. I'll just do it.
Yeah, take your time. In a way, I'm a straightforward person. I try to solve problem as quick as possible. Okay, but the email, because I'm not full-time with Louis, so maybe every other day I just check the email once. And if your email doesn't go through or your email has something that I cannot see, so for example, some students send me the iPhone picture, but that format on PC I cannot see. Okay, then I cannot solve your problem. So be direct. Facebook is easier, faster. And usually if you do need to have some help, I use a room to help you. That would be faster than keep the email exchange. That actually take longer time, right? Actually, when I see it, it's 2 days later. So if you have a question, you can share right now. Okay, I'm going to answer you. And Monday meeting is supposed to help you to solve the problem. I go over the fundamental part, but the detailed teaching, you have to watch the video because it takes so long. You know, every video is like 2 hours, 3 hours. So only watching the video is take a long time. If I make it as a regular teaching, then I may need to have teach you every day. And nobody can do it, right? Nobody can do it.
Professor, I'm
Even if, yeah,
able to share my screen. It is asking for request.
yeah, you share your screen right now. So your name is what?
Bhanu Prakash.
Prakash, right?
Yes, Professor.
I make you a co-host as well, so you can actually share your screen.
Okay.
I'm sorry.
Are you able to see my screen, Professor?
It's coming, but I haven't seen it yet. Yeah.
This is what it is showing when I.
It looks like you may not know the person. I'm not sure, okay? I'm not sure why Facebook check AI check that you don't know me.
I don't know, but I tried to send a message over here. I just
You cannot send message. You just add friend.
no, it is not allowing me to send request. Professor. This is what I'm getting.
I don't know what happened, but usually it doesn't happen this way, okay? You don't know if you got this message it because you send a message, then it's possible. But usually add friend, it shouldn't be a problem. Okay, let me do the other way, okay?
Okay.
Let me check. Okay, go to your page first. Go to your page.
Yeah, Professor. Yeah,
Okay,
this is my page.
so that's your page. Can you copy the Facebook address to the checkbox?
Yeah, sure.
Yes. Then reverse way, I add you as a friend. Then that should be okay.
Yeah.
So you go and then put
Thank you.
put in the checkbox, not in Facebook, in the checkbox, here. Okay, I mean correct.
I just sent you a message, Professor.
Okay, I send a friend. Please add me. I send you a friend request. Okay, you approve me as a friend, then you should be able to send me message. Is that okay?
Yeah, Professor.
But anyway, right now we don't submit this way since you are in the class. So you show me your problem if you have.
Okay. Yeah, thank you, Professor. I got it.
No problem, no problem.
Yeah,
That's
so
that's
maybe
where
I
we
will
should.
just, if I have any problem, I'll just message you in Messenger, Professor, so that we can connect.
Yeah, that's faster than you send email. A lot of email I cannot handle because number one, it's so hard to read the email to figure out what math went wrong. So you don't have question right now?
No, Professor. Actually, I had question
Okay,
last week assignment, but
okay, no problem. When you have question,
yeah.
let me know. Okay.
Yeah.
Any other student has question? I set up a Facebook just because that is actually I can talk to you faster, okay? Because I check Facebook almost like every minute. So I can guarantee that within a day I'll reply you, okay? That's whenever I don't have class, I would actually message you. But the email I cannot guarantee because email I read the Louis Facebook email maybe every other day, maybe 2 days, 3 days. So when I actually read it, you see sometimes there's a delay. I cannot guarantee the email. Okay. Any other questions so far? Okay. So over the year, we try to set up, we got the recording, okay? We got the recording for every session, every lab, every homework. So they should teach you what you need to learn in terms of programming skill and also the set up the metrics and all the knowledge you need. Okay, we try our best to do it. But if you still have question, I would suggest you to go through the meeting day like today. I will answer the question, whatever you have, up to the level that I'm able to handle. Okay. Or you send me the friend request in Facebook. Then if there's a room needed, I will room you. Okay. I'll room you. But usually I don't answer the question like proofreading of your homework. Okay. We don't do that because you submit, I will grade it. Okay. Proofreading, actually, I have too many students. Say if we have 20 students and then each student had one homework and some quiz, I need to proofreading. That's a lot of work. Only grading is a lot of work, not to say that proofreading. So we don't do proofreading. You actually submit our grade, okay? Okay, so today we just go over the problem 4, which you understand what is the purpose of the problem 4, programming assignment 4. And then this week, you need to finish the Denavit-Hartenberg metric. Okay, so this one, in addition to the 4 frame that you have, you need to know about the frame-to-frame differences. Okay, so in each robot, you actually set up your kinematic diagram, and then you have 3 joint, you will end up with 4 frame. And then Denavit-Hartenberg scenes is to talk about the frame-to-frame setup. So you can set up your homogeneous transform metric in a systematic way. So then you need to know about the Denavit-Hartenberg frames. Okay, this one actually there's a video on it, but here I just talking about the fundamental idea why we do this. Okay, so you must follow the right-hand rule. Each of the axes must follow the right-hand rules. So some is correct, some is incorrect. Okay, so let's assume that your x is right here, your y is right here. You cross over, then you get a z in this direction. Okay. So this one is wrong. If you cross x is right here, y is right here, that's wrong. This one you have let's see, you have if your x is right here, your y is right here, then this is correct, this is wrong. Okay, because you cross over, your x cross over, your palm, your finger is this way, your palm is this way, then you cross over, your g is this direction. Okay, this actually assuming it's 90 degree, 90 degree, 90 degree here. It's 90 degree this way, 90 degree this way. Okay. So 3 joint, 4 frame at least. Okay, this including 2 rotational joint, 1 prismatic joint. Okay. So there is a set up the x direction, y direction, following the 4 rule that we talked about in kinematic diagram. Earlier, there's a talk about it. Okay. And then after that, you set up your frame x, y, z. This is actually a little bit confusing and tedious to determine the theta x. So there's you have to understand what it means by the angles, and then your order x n minus 1. So if you have the x0 versus x1, so the theta angle is your S rotation of x0 according to x1 along G0 direction. Okay, so this is theta 1 is when this rotate, you do rotation in this direction. That's the theta 1 you have. Your x1 is rotating from here to here. Okay? That's your theta 1. So you need to set up theta 1 is frame 1 versus frame 0. Theta 2, this theta 2 actually is frame 2 versus frame 1. But in this case, it look like the frame 2 and frame 1, they actually, the frame origin point, they actually overlay each other. So it's a little bit more confusing in this case. But you need to go through every single one. They'll teach you how to set up the Denavit-Hartenberg 4-parameter, the theta. Theta is the rotational one based on what? Based on your rotational joint. Alpha is the fixed angle change. Okay. And then displacement also has a R according to the extension. It's a movement displacement. Another one is D. D is a fixed size. I'm sorry, I'm opposite. R is the fixed size. D is the extendable part. So this 4-parameter is one fixed rotational angle, one fixed angle, one displacement extension, one the fixed extension. Okay, the 4 number, and you put them together, you will get your Denavit-Hartenberg matrix systematically using the theta, alpha, D, and R. These 4 number, you will get the Denavit-Hartenberg. So this is actually a systematic way of setting up your Denavit homogeneous transform matrix using the Denavit-Hartenberg parameters. And then there's a Python coding associated with it, showing you the example of how so this one is downloadable. Okay, this one is downloadable. Okay, so that's this week's main topic is this Denavit-Hartenberg matrix. Let me see if the other topic important. So this Monday session, we usually help you to to answer your questions, and also if extra time, then we go over to talk about the fundamental nature or idea of why we do this. Okay, but the detail part, you still need to watch the videos. So this week we are on this Denavit-Hartenberg, and let's look at the inverse kinematic as well. Inverse kinematic. First, we already talk about the workspace. Workspace is the preparation to do the inverse kinematic. Okay, so inverse kinematic. So inverse kinematic is the opposite of the kinematic. Okay, so forward kinematic is that we do have this theta 1, theta 2, A1, A2, A3, A4, the different joint parameter, and we are going to try to figure out where the XYZ is. That's forward kinematic, okay? We use joint variable to calculate the n effector's position and orientation. That's called forward kinematic. Inverse kinematic is that I do know where I want to go, XYZ, where the XYZ should be. Then I have a fixed number for A1, A2, A3, A4, because that's the robot arm length, so that's fixed. But what should the theta 1, theta 2 be? So you need a sub-equation. So that's called inverse kinematic. From your n effector position and orientation, backward to calculate your joint variables. So figure out how much the theta 1 or theta 2 should be. So first, you still need to set up this kinematic diagram according to your robot. Okay? And then you kind of need to solve the problem by metric to do backward. But usually the metric is very difficult to solve because so many complicated nonlinear equation need to solve. So a better way is that you just go through the graphical way to solve the equation by your knowledge of trigonometry. Okay? So it's kind of solving a trigonometry problem based on whatever xy you have to figure out what theta should be. Okay, so there's a math. We talk about some of them. So this actually is not really for the inverse kinematic. The homework may not be using your metric. Maybe just use some of the trigonometry way that will solve the problem in an easier way. Okay, so here we do have two examples. So you need to watch this video. They'll tell you how to calculate those theta back by using trigonometry. So forward, let's go over the idea one more time. Your forward kinematic is from joint variable to find the n effector positions. Your backward or inverse kinematic is opposite from your n effector where your robot should be to reverse calculate your joint variable, where what joint variable should be set up, how much rotation you need to do. Is that okay? Any questions so far? Any questions so far? Okay, so basically Monday we use it for discussion of the questions and also go over the fundamental idea. We only touch the idea. Detail calculation or math, you still need to go through the videos. Okay, and if you figure out that you have some problem, you have some question, an easier way to reach me is always come to here Monday meeting. That's one way. Second is that if you really urgent, you go through the you go through the Facebook. I will add you as a friend whenever I receive the request. If you do have those kind of problem, like you cannot add as a friend, I don't know why it happened, but in that case, let me know. I just add you a reverse way, okay? From my side to add you as a friend. So send me your Facebook link instead. If you don't have Facebook account, then it will be more difficult because I only can talk to you through email. Okay, then that's harder. Okay. It doesn't mean that I don't like email, but because that I don't read the email every day. That's the problem. It may have longer delay. Okay. Okay. If no question, we are here up to here today. Any more questions? Okay, no question. That's it for today. Okay. See you next time.